Today we're looking at square roots and real numbers. To show you square roots, I want to show you squaring things first. I think from last night's homework, can you guys help me give answers? What's 4 squared?
16.
2 squared?
4.
8 squared?
64.
12 squared? Okay, so square root, all roots undo exponents. So square roots undo squares. So if I want to know the square root of 16, it means is 4. So square root kind of means what, and I want to be clear because this is going to be a little different later in the year. This is what we call the principal square root. By principal, it means it's 4, the positive version. Negative 4 is also a square root of 16. Because what's negative 4 times negative 4? 16. So there's actually 2 different answers. For today, we're focusing on the principal square root. Okay, just the positive answer. But no, there is a negative version too that works. Because negative 4 times negative 4 is also 16. So square root of 4 is? 2. Square root of 64. Square root of 144. So I'm just showing you guys that is the inverse operation, right? Are you seeing that? So when I'm trying to find this, can you use division to get the square root?
Yeah.
Kind of. You need to know the fast fact of what times itself. You can't divide by 2. You can't divide by 4. Right? What's the square root of 100? 10. Right? And you just kind of have to know 10 times 10 is 100. Now, one thing that'll happen is some numbers will get bigger than things you have memorized. You're gonna want to guess and check, but you can guess and check with intent. Like if it's 400 something, 20 squared is 400. So I could start by the 20s, right? So you use some things that are nice to get close, and then kind of whittle it down. And some of them might not know. What's 16 times 16?
136.
136?
No, it's like 172. No.
What's 16 times 16? 160 plus 60 plus 36.
256.
Yeah, 256. So not many people are looking at 256, right? But if you know you need the square root of 256, you probably know something like 12 times 12 is 144, right? And the only way to get a 6 in the ones column then would be something like 16 times 16 or 14 times 14, because that gives me this gives me 36, this gives me 16, both which would give me 6 in the ones column. So you can use some you can be intentional, not just random guess. You can kind of use things that are going to multiply to give you the right ones value first, all right? Do you see what I'm saying on that? I'm not expecting you to have 16 times 16 memorized. No, you don't. No, this isn't intended to have you write out. I'm giving you a hint.
Oh, I didn't read that.
No, this is good to have down. So, all right. So you can kind of get close with something that's nice. All the 10s are easy to square, right? Like 30 squared, pretty easy, right? 900, right? Okay. So that'd be my advice. Get something close and then whittle it down by knowing what you want in your ones column.
What would 900 be? 90?
No, square root of 900 would be, it wouldn't be 300. 30. It'd be 30. 30 times 30 is 900. Okay, I want to show you one more type of problem. If you had something like the square root of 4/36, it's just 2/6. So you can take the square, you just take the square root of 4 and you take the square root of 36. Right?
Yeah.
This is 2. This is 6.
How can you tell it's divided by what?
You can't divide it. You have to know your facts. What times itself?
Oh.
The same factor twice.
It have to be the same factor. What factor times that same factor?
Yeah, so you can't use division or something. You have to just know your facts.
But you could use
You have to divide by that perfect factor.
That
Yeah,
is larger. It must be harder then.
it does. When numbers are larger, it is more difficult because you don't have the fast factor to pull from. But you'll be able to do it. What about this one? Square root of 1/81.
181.
1/9. The square root of 1 is 1, because what is 1 times 1? 1. Okay, cool, we're good.
1 times 1.
Let's get to these notes. You've done these probably once or twice, but it's a thing that kids forget a lot because it's very wordy. And this is real numbers. So within the real number, we also have not real numbers. Let me make that over here. Not real. So not real numbers would be like 6 over 0. Or something like the square root of -4. Can you have a negative square root? No, because anything times itself is always going to be positive, right? Positive times positive, negative times negative. There's no way to get a negative. Until you get to advanced algebra, trig, and you'll learn about these things called imaginary numbers, but don't worry about that now. Yeah. I'm going to tell you this is not a real number, and it's true, but then you'll learn about this thing called an imaginary number later. And it's a real thing, but it's imaginary. Okay. So, let's look at an irrational number. An irrational number, I like to think of as numbers that can't be a fraction.
Are we supposed to be writing this?
Yeah, on these notes here. So, some examples of irrational numbers are pi.
Can we write irrational? Can't be a fraction.
Yeah, I'd write on. Okay, pi is irrational. If you get a decimal, 261419 ... that ... saying it doesn't end and there's no pattern, that can't be made into a fraction. Another good example of an irrational number would be something like the square root of 5. If you get the square root of something that's not a perfect square, you're going to get a decimal that goes on forever that is just like a bunch of junk that doesn't make sense, kind of. It's not going to be a nice number. So that can't be made into a fraction either. Square root of 5 is going to give you a decimal that doesn't repeat, doesn't have a pattern, just keeps going forever. All right? Makes sense. Irrational, it's kind of like these long things it's hard to make sense of. Now, a rational number can be made a fraction. And so next to it, maybe like, I'm just going to write the word fraction. A rational number can be made into a fraction. All right? So some examples of rational numbers would be like 1/2. -3. Who can make -3 into a fraction for me? Rocco? Well, -3 over a positive 1. But yeah, you just put it over 1. It's a fraction. You got it. -0.27 repeated. I'm not exactly sure what that fraction is, but I'm letting you know if it's repeated, it can be a fraction. 0.56. 0.3 repeated is a third, so that's rational. So all these numbers I'm giving you here can be made into fractions, therefore they are rational. Okay, now, notice how integers, this next thing down, integers is inside of rationals. That means all integers are rational, but not all rational numbers are integers. Okay, so here's what the definition for integers is. Whole numbers and their opposites. So the definition for integers is whole numbers and their opposites. So what that means is 0 is a whole number. 3.
We never got the sheets.
Yeah, we did.
One person per table is asked to get them out of the homework basket, but okay. That means -64 is an integer because it's the opposite of 64. -2. So all whole numbers and their opposites are integers. Notice all those numbers I wrote can be made into fractions, so they are also rational. They are also real. So as you get more specific classifications, they fit within more of the loops. They have more classification. Just like in science, right? There's like the animal kingdom, and then there's more specific, right? Kingdom, phylum, class, order, family, genus, species. The more specific, they're in all those things. Can you tell I used to teach science? So they're in more classifications. So real number is the most general. As you get more specific, it'll fit into different categories of classification. So whole numbers, 0, 1, 2, 3. You might hear people say it's the natural numbers plus 0. I don't think you need much more on whole numbers. Are whole numbers integers?
Yes.
Yeah. Are they rational?
Yes.
Yes. Are they real?
Yes.
Yes. Okay. And then natural numbers. It's just, you eliminate 0. So natural, and you probably, I don't think on your homework it's going to ask about natural, I don't think. I don't really use it much, but let's leave it on there for now. Cool? So flip over your notes for some practice. And you can flip back and forth here. It wants you to give all the classifications of those first 4 numbers. So, who can give me, I like to go top to bottom. I say, is -1 real?
Yes.
Is it rational? Yeah, -1 over 1. Is it an integer? Yes, it is. Good guess, though. That's good mistake. It's an integer because it's an opposite of a whole number. Is it a whole number? No, so then I stop there. So I kind of like to run down the list and then you stall out at some point. So square root of 5, is it real?
Yes.
Is it rational?
No.
No, it's irrational. That's going to be an ugly decimal that goes on forever and never.
Why are we writing it's real? Isn't that not one of the categories?
It's the categories of all
It
of
just
them.
doesn't exist.
Okay, what about 0? Is it real?
Birth certificate.
Is it rational?
Yeah.
Is it an integer?
Wait, is this number 0?
Yep. Is it a whole?
Yes.
Is it natural? No. Okay.
Wait, what's the natural?
It's like the counting numbers 1, 2, 3, 4. 0.2379. Is it real?
Yes.
Is it rational?
Yes.
It is. So 2379 over tens, hundreds, thousands, 10,000s. There's your fraction. Is it an integer? Is it a whole number or its opposite? It's a whole number or the opposite? No, so we're done at rational. So that's how you're going to classify. Cool? Take about 3 minutes, look over the rest of this as a table group, and go over anything that you think is going to be too difficult, because this is kind of notes. All right?